This project is about gribouillage and particles, or to say it with a long title, a pencil-drawn doodle-like rendering for a particle-based fluid simulation with real-time interaction. This project was made by my partner Elise Klay and myself, Jessa Bekker, for the Introduction to Computer Graphics course taught by Professor Pauly at EPFL in the fall of 2012. Let's see a small demonstration first. We used a particle-based simulation tool from Alex Nasser and added a doodle-like rendering. With the tool you can attract particles and repel particles, and choose different kinds of particles. You can add plasticity or you can add elasticity. We used metaballs to render the particles. This is a classic technique for particle rendering. We chose to implement a drawing-like rendering because it gives a unique look to the application. For the effects we wanted to add, we tried to find our own solutions. So, each particle is rendered as a metaball. A metaball is bright at the center and grows darker towards the edges. It is a function of the distance towards the particle, and this is the function we used. Once we have all the metaballs, we can just add them up to get a blob texture, which looks like this. With the blob texture, we can easily render the white parts with a doodle texture and the black part with the college paper texture or slides, like we did here. Simple edges can be added by making the gray area of the blob texture black. Once we had a simple rendering, we wanted to add some cool effects. A first one was making the moving particles look like drops. Therefore, we added two effects. The first one is making the metaballs longer in the direction of the velocity as a function of the velocity. The second one is making the tail pointy and the head thicker. An important thing to know for the implementation is that for deforming a metaball, you actually have to deform them the inverse way. For the first effect, to make the metaball longer in the direction of the velocity, you actually have to make the distance to the center of the metaball shorter. This is shown here. For the second effect, the pointy tail and the thicker head, you have to make the triangle upside down to get the desired effect. This is what the drop-like particles look like. Another effect we wanted to add was nicer edges, hand-drawn edges. We made a hand-drawn texture of an edge ourselves. The vertical coordinate of the texture is picked based on how far from the center it is. Actually, for this the blob texture is used again. On the color of the pixel, the inverse of the metaball function is applied. The result indicates the distance towards the center, and hence, if there is an edge, and if so, which part of the edge it is. The horizontal coordinate of the texture is chosen based on the location on the screen. This way, the edge will be more or less continuous. A last effect we added was make the doodle texture change with velocity. One aspect is rotating the texture coordinates using the average velocity. A second aspect was using the metaball texture as an alpha channel. The biggest problem we faced was merging two frameworks. And since it was the first time we worked with OpenGL, of course, there were a lot of question marks there as well. An idea for future work is using our framework to make a real game, opposed to a way of distracting people during a presentation like we did now. Thanks for listening.